Alright guys, welcome back to uh, functions. This is Resh Mahaber signing on, and we're going to start covering a big section on just functions, how they work, and how we should be regarding them in regards to mathematics. Now, if you recall what a function is, um, it's really simple. It's really just a machine, okay? You just plug some stuff in, but you should only get, and this is the key part, you should only get one thing out. Okay, so when you start talking about multiple inputs into a function and getting one thing out, then we're talking like three-dimensional calculus, multi-dimensional calculus, linear algebra, really high-tech stuff. But most of the time, we look at functions. We look at it as plug in. So let's call this my machine. And we normally give them names, F, G, H, P, right? We normally plug in inputs, and let's call this function the F function. Then F, whatever F does, it works on it, and it does its stuff. It could be the squaring function or something weird looking. But anyhow, it does whatever it does, and what it pops out is f of x, not f times x, but f of x, meaning that f did its work, and this is how we will symbolize that f did its work on x, and and this is the thing that it popped out. Most of the time, back in the day, before we knew functioning languaging, we would just call this y. Okay, so it's pretty simple, right? So that's what we'll be dealing with: singular inputs, getting out exactly one thing. So not everything is a function, so we should be careful on what we regard as functions, okay? So I'm going to give you, for example, let me give you one of my, the basic parent functions of the quadratics. We'll call this x squared. Quadratics degree 2's x squared. All right, and most of the time when we make a function, you'll notice that we normally just plug stuff in and get stuff out. So I'm going to plug some stuff in, right? Input output table. We normally make this an XY table. Some people call this a T-chart. If I plug in 1, I'll get out 1 squared, which is just 1. As a matter of fact, I think we could do some of this work in our head, so I'm not going to do it, which is just 1. Plug in 3, you get out 9, right? What about this? What if you plugged in negative 1? You would also get out 1, right? Don't forget, caution, that when we plug in negative 1 and it's being squared, it's squaring the negative as well, right? Because that's negative 1 times negative 1, which gives us 1. All right, so that's also 1, and same thing like negative 3, you'd get out 9. Now, why am I using these two examples? Because I want to emphasize some stuff for you guys. I want to emphasize that, notice it says for every input, you get one guy out. It doesn't say that this guy is paired to that guy, like 1 has to go with 1, because if you notice, this guy and this guy both have the same output, but it was still just one input now, so what's the point? And here's the big moral of the story. For a function, and I'll write this in big and bold for you, for any input, you should get out 1. And maybe I don't emphasize that anymore, maybe I'm being extra, but exactly 1 output. That's it. No more, no less. You get an input and you get out exactly 1 output. Now, were these the only things we can plug in? No, obviously we could plug in way more, and the list goes on. The list goes on. This can go on forever. And this can go on forever, right? Because you'll get the same output to be paired up for everything that you plugged in. Well, guess what? This is where we'll give you some more stuff. All the possible things that you can plug in has a special name. Now remember, it's all the things you can plug in, not everything in the world, okay? So this is called the domain. So this is all possible inputs. And why did I draw it here? Because this symbolizes all the input, where the inputs are is right there. Okay. Now, and then obviously these are going to be linked by F into another big set. Now, some of you guys may have already seen this before. We call this the, if you got it, say it. Yes, it is the range. The range. And the range is a lot like the domain in the sense that it is, this one's all possible inputs. Range is all the things you can possibly get out. So all possible outputs. Yeah, it is fairly simple, right? So this is just, so you just gotta get the languaging down. Once you get the languaging, then everything just turns out to be beautiful, wonderful, and things are, like, start to link up really nicely. Okay, so let's move some of this aside and try to get some other stuff going here. So let's take a look at this. if we look at just all the inputs, maybe I zoomed out too much. If you look at just all the inputs for this, okay, if you look at just all the inputs, I'm going to call the domain down here. So domain are all the possible inputs. If you look at the squaring function, you got to think to yourself, is there anything I can put in there that'll blow up my machine? That'll blow up my machine. And obviously you start thinking to yourself, you start saying no. So if you look at this, the domain for this guy will be all numbers, or all real numbers. Now this is the harder part when we start talking about the range. The range are all the things you can get out. So you gotta start thinking to yourself, can I get all numbers out? Right now we only have whole numbers. Can I get other stuff out, like square roots and cube roots and all this other stuff? To be honest with you, we can. We just have to plug in the specific input. So this guy is also all real numbers as well. And most of the time I'll abbreviate it like this, because how you'll see it in most of mathematics. Now, we will get down to the brass tacks and nitty-gritty details of how we do this later on when we talk about domain, because this is an ongoing story with us, and I'm probably going to talk about multiple topics with functions. So right now we're just talking about how functions work and how to input them into a function. So there's a big piece of this puzzle, and it's called so getting the input outputs that we did here, it normally has different languaging to it. So we we could input more than just numbers into our functions. We can put variables and everything, and a whole bunch of other hoopla. So let's say, for example, let me give you a different name for a function. Let's let g of x equal x squared plus 4 over 2. Okay, now I know this looks really weird because I told you you can input variables and stuff in here, right? And we're going to do a classic example that you'll see. It's called the difference quotient. And I do a lot of these in my course because you're going to see a lot of them when you get to calculus and you start calculating what's called the derivative. So let's talk about this. And this is how I want you to think about this. Do you see this x? Core it out. Think of it as a dummy variable, because remember, it could stand for anything. Anything. So it should be g of a bubble equals the bubble squared plus 4 all over 2. Now what does that mean? Is that if they're asking me for something, I could just think of it as filling it into the bubble and then evaluating this, and the thing that pops out is good to go. So for example, let's say they say this: find f, can't say f, where you working with g here, g of -8. Okay, then what does that mean? Well, thinking about this, right, I'm going to shove -8 into both of my bubbles. So this becomes -8 squared plus 4 all over 2, which is 64 plus 4 all over 2. And yes, you must be good with arithmetic, guys. People think because we have calculators now, we're null and void with like arithmetic. Actually, there's more of a demand now for arithmetic than there ever has been, because calculators will give you the information and the numbers, but you still have to interpret it and think about whether or not the actual numbers are where they're supposed to be at. That's why approximating is such a giant thing, because it's mathematics without the calculator. Alrighty, so basically what this means now is that when we plug in -8, we get out 34. And one way we could write this is -8 in, 34 out. So note, we are dealing with a function, which is also like a graph. So you could look at it as a coordinate point, but this is one way of looking at it. You get out 34. So this is our answer, and this is another way of interpreting it, our answer. Okay, so fairly simple, right? So let's get really nitty gritty, if you will. I don't know how to zoom out. Let me zoom out. Zoom out. Let's zoom in. There we go. Sorry guys. I'm getting used to technology, as you see. Let's find this guy. Find this guy. I want you to let our function no longer be g of x. Let it be f of x equals 1 over x. Something fairly simple, right? But this is what's going to make it dirty. I want you guys to find f of x plus h minus f of x all over h. Now people look at this and say, oh my god, it's so weird, it's so awful, it looks terrible. But here's the point. These aren't f times h's and f times x's. These are telling us to do something first. This is telling me to do something, and this is telling me to do something. So these are two separate problems you're going to have to go to the side and do. So what are you going to have to do? One, so here's Rush's big bullet points here. Oops, I didn't switch colors on you. Here's what you're going to have to do. You're going to have to go to the side and one, find these pieces first, these outputs. Okay, so that means there's some work you're going to have to do here. So let's do the work here. So I need to do f of x plus h. Now remember how we think about this. There's a core here. So I'm going to draw your little think bubble in the corner. Okay, here's your think bubble. And what this means is f of whatever you plug in is going to be 1 over that thing. Right? So the thing I'm plugging in here is what, guys? X plus h. So we're going to go ahead and say this is 1 over x plus h. Boom. Easy, right? And then the next guy is f of x equals, well, that's already the parent function, so we really don't have to do anything about it. Done, right? Easy, but we're not done yet because our job is to find this. Right? So what do we got to do? So part 2, after we found all of our pieces, part 2 is finally substitute the pieces in and solve. So here we go. Substitute the pieces in and solve. So where we go. So in f of x plus h, I'm going to put the 1 over x plus h. Oops, wrong color. Didn't want green. Let's go back to black. 1 over x plus h minus 1 over x, and this thing is all over h. And a lot of people are freaking out because they think that once again they could just leave out all of their old information of how they do mathematics. No, this is the ante to play, ladies and gentlemen. You got here because you know that stuff, so we have to use it. So what do we do here? Remember, our job is to find this, meaning we're evaluating this function. It is not an equation. Don't you dare try to clear out these fractions. We have to find the CD and add our numerators together. Now, you'll notice in my instructions, I will never just say find f of x plus h minus f of x. See this h? We're always trying to get rid of him. And you'll understand more about this when you get to calculus, but that's the major goal of this problem, is to get rid of that factor of h. So this h, I'm going to write him in red because he is awful and we need to get rid of him. Because calculus-wise, we're going to do some stuff called limits, and we're going to take him to 0, and you can't divide by 0, so if you put him in 0, that makes no sense. Anyhow, that's all. Let's find the CD. In my numerator, boom, 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 boom. This needs a x plus h, this needs a x plus h, this needs a x, and this needs a x. Done. Alright, so what does this yield me? This yields me something that looks like this. X minus x plus h over x times x plus h divided by this factor of h that I do not like and I'm trying to get rid of. Alright, so let's see if I can handle some mathematics. And you notice a whole bunch of cool stuff, and this should happen every time. Stuff should simplify up top in the numerator of the numerator. It should simplify. And why does it simplify? It simplifies because there's actually some other mathematical jargon that's going on here with graphs. I wish I could teach you guys calculus right now, but we don't have all the tools yet. So here we go. So in my numerator I have this. Now watch the birdie here, because if you don't, you may miss it. So this is being divided by h, which means this is going to be multiplied by his reciprocal, which means that and that factors and gives you negative 1 over x plus h. I'll write it backwards since I already started writing it. Done and done. Now remember, what was our goal? Our goal is to get rid of this icky factor of h. And if you notice, he's gone in our last expression. So this would be our answer, ladies and gentlemen. Boom. Not too hard. So what does make it hard? It's the function. The function makes it hard. Okay, so with all that being said, here we go. Let's do one more, and this one's going to be a little bit dirtier. It's probably going to take a little bit more skills than we actually have seen before, and that's going to require something else. Okay, so here we go. Let's try this guy. Let's let f of x Okay, let f of x equal this guy, square root of x plus 1. Okay, well, no, let's not make it x plus 1. Let's make it x plus 7. Why not? All right, why so? Because now this is what we want to find. I want you to find f of x plus h minus f of x all over h, right? Once again, I have to find those two pieces. But this I want you to do, don't forget, we need to remove the factor of h in the denominator. Okay, so that's this blob. We don't like it. It's got to go. All right, so first things first, what are the two things we got to do? If you need to, stop the video right now, go back, and look at what the two things are. One thing you got to do is first figure out the pieces. So here we go, f of x plus h. And I would encourage you as you do these problems to go through and stop the video before and attempt it. That way you can actually see if your work matches up with my work. So we're plugging in x plus h. Now, once again, think of this as a bubble. Let me draw your bubble. What does this function do? Anything you plug in equals square root of crap plus 7. So if I'm plugging in x plus h, that's going to be x plus h plus 7 minus, okay, so that's that. That's that first piece. Now, f of x, I could put that off on the side, but they kind of already gave it to me in my original function once again. So let's go ahead and input our pieces. So this is step 1. Let's go ahead and plug stuff in. So to find this, we have f of x plus h minus f of x over h. And a lot of people are going to say to me some weird stuff right here. This becomes square root of x plus h plus 7, which is the first piece, minus square root of x plus 7 all over h. Now, where do we go from here? All right, so this is where it's going to get good. You need some fancy mathematics, which is really not all that fancy. And this fancy mathematics is called the conjugate. Because once again, what is our goal? We do not like this. He has got to go. Those factors of h that is in the denominator. The conjugate. What is the conjugate? Well, good news. The conjugate is nothing from the past. If I asked you guys to factor this, a squared minus b squared, 99.9% of you could factor it and say that this is a minus b, a plus b. Well, this had a name. This was called the difference of squares, and it gave you two factors. Well, they are conjugates of one another. They are pairs. They roll together. So basically, if one is missing, if I put the other one in, it turns into the difference of squares, right? Doesn't seem too big of a weird thing, right? So let me show you what we're going to do with this. Okay? Let me show you what we're going to do with this. So this means this. If this is equal to this, and obviously, if this thing is equal to this thing, it doesn't really, we can simplify it, except check this out. What if I said that this is like a minus b? What would we need to multiply by? Well, everybody would say in their head, we need to multiply by a plus b. And that just makes good sense, and our answer will end up being a squared minus b squared. And what's the motivation behind this? I need to get this h out of here. I have no way of doing it. The roots are in the top. It's no bueno. So how do I get rid of it? Well, here we go. What would be the a plus b? If this is a minus b, what would a plus b is? Well, we're claiming that a is square root of stuff. So here is square root of stuff plus square root of some more stuff. But notice, this is once again an expression, not an equation. So what does this mean? This means that we can't clear fractions. We must multiply by 1. So whatever I do to the top, I'm going to do to the bottom, because then it'll keep this as a 1, which means that if I multiply anything by 1, I'm not changing the expression at all. Boom. So what do I end up with? Well, here's what I end up with. In my numerator, if this is a minus b and a plus b, then what do I end up with? A squared minus b squared. So that's a, that's b, right? So here we go. We end up with a squared minus b squared. That's in my numerator. Now what do we do all the other crap? What do you mean by the other crap, Rush? I mean this. This h is going to be multiplied by this stuff. Yes, it is. I'm not going to multiply it through. I'm just going to write it down here. But if you really observe the numerator, look what happens. The square and the square roots undo each other. And that minus sign, because we're subtracting this entire quantity simplifies to x plus 7. That means we're still subtracting the entire quantity. We're still going to have to distribute a negative across. Alright, so mathematics to me is all about looking in the future before you get to write it down. Anybody see what's going to happen? Distribute the top out, we get this. And then this is where a whole bunch of magic happens. All those guys go away, leaves you just h on top. So you get h over this CD. And then look at what happens. The h's factor out. Once again, we were trying to get rid of it, and we did. So conjugating helps us, or putting in a conjugate helps us get rid of this extra factor of h. It's really that simple, and we are ready to rock and roll. And what is a conjugate? It just relies on this fact that we have the difference of squares staring us in the face. Alright guys, so this is basically it for what you'll have to deal with as far as simplifying functions and doing things with functions. Next video, we will talk about the domain, the range of functions, and most importantly, probably my favorite, which is piecewise functions, how to input in them, how to get outputs, which is really the same as what we did. You just got to learn how to read them. Alright guys, this is Resh Mahaber signing off. So remember, in order to go somewhere you've never been, you're going to have to do some things you've never done. Step out, expand your mind, evolve, and I'll see you in the next video.